All right, gentlemen, if we just take a look at our optional homework, I'll just kind of start showing you some of them. Really going to focus on the last one. I'll probably do 2 examples of the last one. This will be good practice for your test, your take-home test, which is really your classwork assignment on March 25th. The classwork assignment will be the test, and it's out of 50 points. Right, so it's just good practice. This was a great review of most of the stuff we've done so far, really since the virtual day. Just a couple things about the test. You would take it from Canvas, download it into your Notability, write in either black or blue. It's just easier for me to grade if it's in black or blue, and then I just kind of grade in red. Make sure to box your answer so that I know this is what your answer is. It's kind of easy to see. A lot of times, if it's on paper, it's kind of hard to read because you cross out and you're like, no, this is my answer. Like, use Notability to keep yourself neat. If I ask you to explain something, please type it. Again, that's just to make sure it's neat and it's easy for me to read. Some of you guys have a little bit of sloppy handwriting, and it'll just be easier to read if you type it. Just never really taken a test on Notability, so just use it to your advantage to keep it neat. I'll start with this first part, polynomials and their roots. I'm just going to start with example or problem number 4. I'll just set it up, and I'll just kind of jump to the answer. You're going to want to be able to do the whole thing, and if you have questions about it, you can email me about it. But I'll just kind of start it, and then an answer key will be posted, just so you kind of have the idea of what to do, and then you can do it out fully on your own. Negative 3, that tells me I have a factor of x plus 3. 2 minus 2i, that's because I have a factor of x minus 2 minus 2i. The only thing is, every single complex or imaginary root also has its conjugate. It always has its conjugate. Why does that occur? Because in my quadratic formula, I have negative b plus or minus square root of, and right in the square root, if you got a negative, that's how you would get your I. The plus or minus, that's why there's always its conjugate in there. Now, to just keep in mind, whenever you have an imaginary root, its conjugate is there. Even if it's not listed, it's there. You got to make sure you write it down. So just get rid of that. It has a secondary root, and that is x minus. The conjugate of 2 minus 2i is 2 plus 2i, right? And that comes from the quadratic formula or completing the square. It always has its conjugate. It always comes in pairs, and we talked about that in class. So now there are 3 roots. I should get something x to the third. I'll just do this kind of quick. X minus 2i plus, or x minus 2 plus 2i, distributing that minus sign. X minus 2 minus 2i, distributing that minus sign. Now, we saw this at the end of the first trimester, and we saw it in the virtual day. You just got to FOIL the whole thing. I would do your x plus 3 last, and I would just kind of start on doing the x minus 2 plus 2i. Do that all out. You should get x squared minus 4x plus 8. That's what you should get when you do it all the way out. I'll just write here, do out. That would be for you to do. Confirm that you get that. You would FOIL these, which we know how to do, and you would get your final answer as x to the third, which you expect, minus x squared minus 4x plus 24. Boxing my answer, I'm writing in blue, and there we go. There's my answer for the first one, right? And that's the important part with here. We want to keep in mind that there's a conjugate that appears with any imaginary root, basically from the quadratic formula. All right, for the most part, you guys did pretty well on this stuff. So I'll just kind of zoom down. Great practice problems. An answer key will be posted for you to check your work. So if you want to do them, you got 1, 2, 3, 5, and 6 to do, and you can check your answer key later on. These will look like something what your test will look like. You'll have one of these. I'll look at number 2. X over x plus 2 plus 2 over. This I should be able to factor. X plus 3, x plus 2. There we go. 5 over x plus 3. All right, so I just factored everything, so now I have it looking a little bit nicer. You want to find your LCD. My LCD right? As we saw from the first long distance learning assignment, is x plus 2 times x plus 3. It's really each denominator, this one and this one, make up this. It's just that it needs something else. So if we multiply, as we saw in the first virtual or long distance learning, we multiply by the LCD, my x plus 2 will cancel here. So I'm multiplying my x by x plus 3. And then my x plus 3 cancels out with this one, and I have 5 times x plus 3. What happens in the middle? Well, fortunately, this cancels with both of them, so I just have plus 2. Okay, so we multiply by the LCD. It makes it not fractions anymore. Much easier to solve. I distribute inside x squared plus 3x plus 2 equals 5x plus 15. Okay, now I want to move things around. I have an x squared and x stuff, so I'm never going to be able to get one of them by itself, so I'm going to have to set it up to be factored. Minus 5x minus 15, minus 5x minus 15, x squared minus 2x minus 13 equals 0. Oh, made a small typo here. My apologies. This should actually be a 2, right? I canceled out this x plus 3 with this x plus 3, so I should have multiplied by an x plus 2. Little typo there. Let me just change that. 10, 8. Right, so this x plus 3, when I multiply by the LCD, cancels with this x plus 3, so I have 5 times x plus 2. Right, nice simple factoring, x minus 4, x plus 2, two numbers that multiply to 8 and add to negative 2. My solutions are 4 and negative 2. All right, now we got to check to see which of these are extraneous. Which of these am I not allowed to use? We look back to the original, and we can see that my 4 is okay. On the bottom, I'm good. On the bottom, I'm good there. On the bottom, I'm good there. So this one is fine. The negative 2, however, plug it into here, I got a problem. I can't plug in negative 2. It'll give me 0. So that's the extraneous solution. All right, so that's number 2 worked out. Number 1, the denominator here for the 2 is just a 1. And this factors to x plus 1. Right? And there was an example just like that. So if you want to do that one out, check the answer key. You may get either both extraneous, one extraneous, or both that work. You can get any combination, just like we saw in the first day. All right, I'm going to do the first one and the second one. I'm going to do this one first and this one second because more people, I was able to kind of do number 2 on the conference, and I feel like it was beneficial to a lot of people. And number 1 was just kind of a secondary thing. So I'll just look at these right here. Number 1, x to the third minus x greater than or equal to 2x squared minus 2. What I want to do here is move everything over so I have it like greater than or less than or whatever, and a 0. I need it to be a 0, so I got to bring this over, and I got to bring that over. X to the third minus 2x squared minus x plus 2 is less than or equal to 0. All right, so I have it now set up. So I have a 0 on one side, my inequality, and then all the terms on the other side. First, I'm going to try to factor by grouping. I could do synthetic division, but I'm going to try to factor by grouping. I got 2 terms, and then I have another 2 terms. So how am I going to do that? Take out a GCF on the left-hand side, an x squared. I'm left with an x minus 2. I see I could have an x minus 2 over here, but I don't. I have a negative x, and over here, in parentheses, which I want it to match, I want that to match right here, I have a positive x. This is a positive 2, and I want it to be a negative 2, so I know if I take out a negative 1, I get my x minus 2. So I get that. X minus 2, it matches with that. So now I'm able to write this as x squared minus 1. X minus 2 is less than or equal to 0. All right, I could do a little bit more. This factor is 2 terms. both are perfect squares, and there's a difference sign in between them, so I can do x minus 1, x plus 1, x minus 2 is less than or equal to 0. Right? So, now I have my three factors. I basically factored my equation right here, my inequality. And what do I need to do now is find the zeros for each of these. Where are the intercepts? I have 1, -1, and 2. All right, so now I draw a number line. And this is where I'll want to see on your test. Write down your zeros, -1, 1, and 2. Okay, now what my goal is pick a test value within the range indicated on my number line. So for example, over here, these are all like pretty negative numbers. So I'm going to pick a test number, test a number such as something more negative than -1. So let's say -2. I want to plug it in either to the original or to like my factors. I generally like to plug it into the factors because it just makes a little more sense to me. -2 minus 1, that's going to be a negative number. I don't know what it is, but I know it's negative. -2 plus 1, well, that's going to be another negative number, -1. -2 minus 2, that's going to be another negative number. That's -4. The product of three negative numbers is negative. Right? Negative times negative is a positive, times a negative turns back to negative. So that area of my graph is negative, meaning it's below the x-axis, and that's what I'm looking for. Nice. Let's now look at a different area, a different interval. Let's look at between -1 and 1. Picking a test number, I'm going to test the number, for example, 0. Erase these. Okay, if I plug in 0, 0 minus 1, that's negative. Plug in 0, 0 plus 1, that's positive. Plug in 0, 0 minus 2, that's negative. Okay, so I plugged in a 0 for all three of these. Negative times positive times negative is going to become positive. So that interval of my graph, of my number line, is always going to be positive numbers. I could pick anything between -1 and 1. 0.5, 3/4, -1/2, but I'm picking an easy number. I'm going to pick the number 0. Okay, let's do our next range. Let's look at between 1 and 2. A little bit annoying because I'm going to have to use kind of a weird number. I'm going to test the number 1.5. 1.5 minus 1. That's why I like to plug it into this, not necessarily the original. Because you could just do it in your calculator too, but if I plug it into here, -1.5 minus 1, that's going to be a positive number. Right? 1.5 minus 1 is positive 0.5. 1.5 plus 1, that's clearly positive. 1.5 minus 2, now I'm at -0.5. Positive times negative, that means I got a negative number in here. All right, so now I'm alternating. I assume this last area will be positive, but let's see. So I'm going to test, again, I'm going to erase these. I'm going to test the number. Any number greater than 2, I'll pick the number 3. So plug in 3 to here. 3 minus 1, that's positive. Plug in 3 to here. 3 plus 1, that's clearly positive. Plug in 3 to here. 3 minus 2, that's positive. So this area is positive. Like I said, I could have plugged in any of these test values. Any of these test values could be plugged in either to your original equation, and I could just use my calculator for that. That's fine. Or I could plug it into my factors. I like to do the factors a little bit easier to see. But if you look at your graph, if you were to graph this in Desmos, you would see I'd be negative here, so below the x-axis, up, then down, then up. Okay, so I'm negative or below the x-axis in this range up until 1, -1. I'm negative from 1 to 2, and the areas where I'm positive are between -1 and 1, and 2 and greater. Let's see what I'm looking for here. I'm looking for where am I less than or equal. So in other words, negative. Well, I was negative here, and I'm negative here. It says or equal to, so that means I got to use hard brackets. from negative infinity up until the number negative 1. Negative 1. And I include that number. This is my negative 1, my 0. I'm using the 0. I'm equal to 0 at negative 1. Where else am I negative? From 1 to 2. And there's my answer. That would be my full and total answer. I didn't do this one all in blue because I think you needed a little bit more kind of showing of things. All right, so there's the first one. There's the first one we did. Now, if this were to say greater than or equal to 0, it would be the opposite, negative 1 to 1 and 2 to infinity, because that's where I'm positive. If it were to say greater than 0, not equal to, it'd be soft brackets. If this were to say, I write it down here, less than 0, it would be the same as what's written in pink, except soft brackets. Right, so it's just like we learned interval notation. It's just like either you use or you do not use hard brackets. Same idea. Okay, I'll do the second one or the first one next. I'll do that over here. And I think that'll kind of clear up a lot of the confusion, and I hope it'll make what is on your take-home classwork test tomorrow in class a little bit easier. Right? Make sure you know how to do something like this, and then we'll take a look at this one. Same idea. I want to move everything over. I want the x squared to be positive. I don't need it to be, but I just want it to be. I think it'll make it a little bit easier. So 3x squared plus 15x plus 18 is greater than or equal to 0. So I moved everything over. I have a 0 on one side, and then I got my terms on the other side. Can't get the x by itself because it's an x squared. I can't combine those. Let's try to factor. Luckily, there's a GCF of 3. I'm left with x squared plus 5x plus 6 is greater than or equal to 0. Very simple factoring. Two numbers that multiply to 6 and add to 5. Here they are. Okay. Since that's just a 3, I can basically ignore it. 3 has no impact. 3 is, if you kind of just look at it like this, 3 is greater than or equal to 0. That's true. So it doesn't really impact it. There's no way that's going to vary. There's no x in there. All it does is affect it a little bit. So it doesn't really matter too much for our factoring. We want to do the things that vary, like the x's. So I have a 0 of negative 3 and a 0 of negative 2, right? 3, this 3 right here is not a 0. There's no x in it. It doesn't cross the x-axis there. Okay, we know this is a parabola, negative 3, negative 2. So we just have to know either does a parabola go like this or like this. We kind of have an idea because we know my a term is 3x squared, so it probably is going to go like this. But let's see. I'm going to pick a number in this range over here in red. Pick any test number. So for example, test the number negative 4. If I plug in a negative 4 into my factors, negative 4 plus 3, that's negative 1. Negative 4 plus 2, that is negative 2. A negative times a negative, that's a positive. So now I know my graph is probably going to look like this. Probably going to look like this. Let's see. Pick a different number for my range in between. A little bit annoying. I got to pick a number like test in between negative 2 and negative 3, negative 2.5. That's why I like to do it into the factors, a little bit easier to see. Negative 2.5 plus 3, well, that's going to be a positive 0.5. Negative 2.5 plus 2, well, that's going to be a negative 0.5. Positive times a negative is going to give me a negative. I'm below the x-axis in that area. Lastly, I'm going to try something more positive than negative 2. So I'm going to test the number 0. Whenever I can, I test the number 0. It's very easy. Obviously, we see here, I plug in 0, I get positive. I plug in 0, I get positive. So therefore, I'm going to get a positive result here. Just as we expected, my graph looks just like the little picture I drew in the top left. It goes down, it's positive, and it gets negative right there. Curves, comes back up, and it's positive over there. So this is the area where I am this is the area where I am greater than or equal to 0. This is also the area I'm greater than or equal to 0. And this is the area where I am less than or equal to 0. Let's see what I'm asking for. Greater than or equal to 0. I include the endpoints. Because it's or equal to. And I want the 2 on the left and the right. So negative infinity up until negative 3. And then from negative 2 to infinity. And I'm including the endpoints, so these should be hard brackets right here. There's my answer for number 1, which I did second. Okay? Again, just as we said from the previous one, if this were to say greater than 0, it'd be the same thing except soft brackets, because then I'm not including my zeros. If I were to say less than or equal to 0, then I would be negative 3 to negative 2, hard brackets, because I'm including my zeros. If I were to say less than 0, then it would be soft bracket to negative 3 up until negative 2. All right, so I hope that clears up a lot of the confusion with this last stuff. These 2 examples are great examples to look at. You can do 3 and 4. My recommendation and what the answer key kind of says is, since these are like bigger ones, like x to the 4th, right, you can just use your calculator, and when you graph it, you just find your x-intercepts, and those are your zeros. And then you use your sign chart and you figure out what's up and down, right? Your test will probably have one that looks a little bit more like this, an x to the 3rd, where it's a little bit kind of got some doing, but nothing too crazy. Okay, so gentlemen, I hope that helped clear up some of the confusion there, and good luck on your take-home or classwork test. Be sure to write in black or blue. Box your answers and type your explanations, just so it's nice and